Is able to hear me here? All right, let's get started. I know the keynotes went long, and it's a long walk over here, and there are refreshments along the way, so many distractions. But we've got a great topic here. I think it's going to be very important and potentially very impactful for all of you. My name is Stephan. I run product marketing here at Couchbase. I'm just really excited to have with me today Patrick Chanezon, who is a member of technical staff at Docker. He's been an evangelist in the past. He's an all-around technologist. And he's going to speak primarily today about how to marry the simplicity and portability of Docker with the power, the flexibility, the scalability of Couchbase. So I'm going to turn it over to him very quickly because he's got a lot to talk about. But before we start, I do want to ask two questions. One, with a show of hands, how many of you have played with Docker? How many of you have worked with the container? For those of you sitting in the front, I would say it's about 90% of the audience. You've tried Docker. And what are we at? 900 million downloads of Docker already? That's pretty good for a product that was released about a year ago. Now let me ask a follow-up question. How many of you, with a show of hands, have tried to run Couchbase on Docker? There are more than I thought. There are about 10 of you there. So I think that's pretty impressive. For the rest of you, I'm going to assume that there is some interest in running Couchbase on Docker, seeing as you're at this session. And the good news for all of us is Patrick has all the answers. So he's going to come up now and present and also demo a running instance of a multi-node Couchbase installation in a Docker container environment. So without further ado, Patrick, thank you very much.
So hi, everybody. And no, I don't have all the answers. I think for the ones of you who have run Couchbase in Docker already, you may have more answers than I do. I'll try to leave a little bit of time for Q&A at the end. And actually, I'd love to get your point of view. What kind of issues did you run into when you run Couchbase in Docker? OK, let's go through it. So my name is Patrick Chanezon. I'm a member of technical staff at Docker. I've worked at many companies before. I spent basically 10 years building platforms at Netscape, AOL, Sun. And then I spent the next 10 years evangelizing platforms at Google, VMware, Microsoft. And I joined Docker only 3 months ago. And there I'm working with Solomon Hykes, the founder of Docker, on the future of the Docker platform. So one of the things, many of you have tried Docker already. One of the things that attracted me to it initially is when I started using it, I had the same feeling I had in 1995 when I used the browser for the first time. I just realized at that time, hey, I was building client-server applications. And I realized, hey, there's a new way of building apps, maybe with HTML and something on the server side that could transform the way we are building apps. And after that, I just spent the next 10 years just building apps that way. And that insight into the fact that we're changing the architecture of how we're building applications, to me, that had a profound impact at that time. And I had exactly the same feeling when I started using Docker. It's the kind of tool that grows on you. The more you're using it, the more you find new ideas for using it in your developer workflow. Before we get started, I'd like to talk about Docker, how I see Docker in the cloud market. And so I spent the past 2 years at Microsoft. So that's a slide I used to show to my team to explain why I thought Docker was important, and especially to Microsoft, but also to all the other cloud players. Right now, we're in that big cloud battle between the 3 or 4 large providers, Amazon, Google, Microsoft, and VMware. And each of them have different strengths. And so I'm using movies here in terms of analogies for what their positioning is. So on the left side here, you have VMware. And they really own the private cloud. They have a big market share in there. People know how to use VMs, and they're very comfortable with them. There's lots of security advantages, as well as consolidation of workloads onto a few machines. But VMware doesn't have any hybrid strategy. And when I was at Google and I tried to sell a Google Cloud Platform to customers, they said, we want hybrid and we want open source. And so to me, VMware, they're positioning right now in the private cloud. They're trying with vCloud Air to get a little bit on the public side, but they have a hard time doing that. It's a little bit like the movie 300. They shout Sparta. They're very courageous, but we all know how the movie ends. So then on the right side, you have Google and Amazon. Both of them are pretty strongly positioned on public cloud. Amazon created that market in 2006. Google joined in 2008, if I remember, with Google App Engine, introducing the notion of platform as a service. While I was at Google trying to pitch Google App Engine to enterprises, I really had the feeling I was like that character Marty into Back to the Future. You know, it's a teenager from the 80s. He goes back in time in the 50s, and he starts playing hard rock to people who don't know rock and roll yet. And there's a big silence after he finishes playing a Van Halen song there. And that's exactly the silence I met talking to enterprise customers about platform as a service in pure public cloud. So I think Google, they have really good technology, but they don't have the migration path that enterprises need to get there. Then there's Amazon, and Amazon, they created that market, the public cloud market, with EC2 in 2006, if I remember. And to me, they're like, you know, these big monsters in Pacific Rim that come out of a fault at the bottom of the Pacific Ocean. So they come out of nowhere, and they just invade the Pacific Rim. So to me, that's what Amazon is doing in the enterprise market. They came out of nowhere. They're invading the cloud market. And from a Microsoft perspective, our goal was to send them back there, as in the movie. Microsoft is very strong in a hybrid. They always had a hybrid story there. So they have, on one side, they have Hyper-V and System Center for setting up your own cloud. And they introduced at Build a new thing called the Azure Stack that lets you install Azure internally. And then they have Azure as public cloud, and they're a very credible player there. So to me, Microsoft, they have that really right strategy of catering to enterprises with hybrid cloud. And so for me, they're field of, like the movie Field of Dreams, build it and they will come. And then 2 years ago, Docker appeared on the market. And the market was kind of stabilized with two categories: infrastructure as a service, where you deal with VMs, and then platform as a service, where you push your code and the platform takes care of scaling it. And to me, Docker kind of created a new category with containers that's between IaaS and PaaS, and the whole market reorganized around it. And to me, that's why Docker is very significant right now, because everybody's trying to determine how they're going to build their apps based on microservices with containers. So Docker is like a shipping container for code. You just package all your dependencies into an image, and then you can run it anywhere. It brings you portability, hence the container metaphor. Containers are not new. You can date them back to the 60s with mainframe, hardware virtualization. Then in the 90s, there were BSD jails, and then later on, Solaris zones. Giant is all based on Solaris zones today. So that idea is really not new. And then Google ran LXC containers coming from Linux inside its data centers as the architecture for running workloads. Then in 2006, infrastructure as a service with Amazon. 2009, Google with platform as a service. And 2013, I think we're living another disruption in that market with Docker. So Docker is super successful, lots of downloads. The open source project is vibrant. There's a big community there. And we just celebrated Docker's second birthday a few months ago when I started, like 2 months ago. So to me, why Docker is successful now is because there's cloud adoption by enterprises. It's happening now. Docker provides portability, which is what enterprises want. And it allows for building these hybrid topologies where you run some of the stuff inside the firewall, some of the stuff in public clouds. There's also another trend, which is DevOps, where Dev and Ops are working together using the same tools and processes. And Docker is a very good tool for implementing a DevOps approach. Another thing I wanted to mention is that Docker is not only like the open source project and what our company is building, it's a whole ecosystem out there. And so to me, the ecosystem looks something like that. At the bottom, you have the new hardware, which are cloud providers or virtualization providers. So VMware, Giant, and the three big ones, Microsoft, Amazon, and Google. On top of that, you have operating systems. And what is really interesting is that in the last year, following CoreOS, most of the operating system vendors shrunk their operating system for the data center, creating small distributions with just the Linux kernel, a little bit of system tools, and then the Docker engine for running your workloads. So CoreOS started that trend, but then after that, Red Hat followed with Project Atomic, Ubuntu with Ubuntu Core, VMware with Photon 2 months ago, and then the most interesting one to me is Rancher OS. They went all the way where in their distribution, you just have the Linux kernel and 2 Docker daemons, one for system Docker, where you run even your system services inside of a Docker container in privilege mode, and then userland Docker for your regular user workloads. You have Docker itself. On the left, what you see is the ecosystem of plugins and add-ons to Docker that are developing, solving particular problems, especially for operations. So Weave is a virtual networking system for Docker containers where you can set IP addresses and DNS names for your containers. Flocker is a way to, actually Flocker may be interesting to this audience because you're focused on databases. Flocker is a way to move containers that have a volume attached, which today in Docker daemon, if you're mounting a volume to your container, it's tied to the specific Docker engine and host where you're running. Flocker allows you to move them, and for that, they're using ZFS behind the scene. And then on the right, you have where the battle is happening right now, which is around Docker orchestration. So at Docker, we have one horse in that race. It's called Docker Swarm. I'll tell you a little bit more about that. Mesos is pretty well known. It's coming from Twitter. It's used at Netflix and in lots of different places. It's designed to manage clusters of tens of thousands of machines. So it's really designed for scale. And we've been working with Mesos to have Swarm as a Mesos framework. Kubernetes is from Google. It's open source. It's also designed in the same way as Borg, the container manager inside of Google, but it's open source, so you can run it in your data center. There's Deis that looks like it gives you a Heroku-like workflow, either with Git source code from Git, you do a Git push and it just pushes your app, or using containers. You can push an image and it will build your image and deploy it. Cloud Foundry, I used to be part of that team at VMware before they did the pivotal spin-off. So Cloud Foundry was really a platform as a service, but they're reinventing themselves right now as a container orchestration engine with a project called Diego, and another one called Lattice, where it's a smaller version of Cloud Foundry with just the, I think they just have the log aggregator and the router, and then Diego for scheduling containers. IBM is betting heavy on Docker as well. They have something called Bluemix, where they have, it's both based on OpenStack and Cloud Foundry, so they have the Cloud Foundry piece, but they also have a native Docker container service as well in there. And then there's Apprenda and Tutum, who are 2 other players in there. So there's a whole ecosystem around Docker. So Docker is a platform to build, ship, and run applications. It's composed of several components. So there's Docker Engine that probably you've been using, but there's also Docker Hub where you store your images, and it supports the developer workflow for pushing images, versioning them, getting them from any machine. Docker Machine is a new tool that was introduced last December at DockerCon EU that allows you to provision in any cloud, like Amazon, Google, VMware, and Microsoft. It allows you to provision Docker or to provision virtual machines with the Docker engine pre-configured with all the security setting on it. Docker Compose is a way to specify several microservices that your app is going to be built on in a simple YAML declarative file, and then you do Docker Compose up, and it will spin up all your containers. Swarm is our entry in orchestration. I'll talk more about that. And Kitematic is our UI that works only on Mac today, and we're working on a Windows version of it. So containers versus VM, that's a question that comes very often. The 2 main advantages of containers versus VM, one of them is they start much faster because it's based on operating system virtualization. So you're sharing the same operating system. There's no hypervisor between you and the host OS. And then the other aspect is that the image layering format that we have allows you to cache layers of images. So if you're using images based on Ubuntu, for example, Once the Ubuntu image has been pulled, all the other images that you're using on that same Docker host that are based on the same image, the image won't be pulled twice. So you don't have to download like 2 GB VM images anymore. So let's take a look at what Docker is based on. Docker is essentially a nice command line that gives developers a simple workflow for creating containers, but containers are essentially based on Linux kernel features, namely namespaces and C groups. So namespaces allow you to isolate a process so that it doesn't see the other processes. It has its own file system. It has its own network. And so it thinks it runs in isolation, while in fact it's running in the same operating system on the same box with many other ones. And C groups allow you to limit the memory that your process has access to, the CPU, the I/O, and things like that. So Docker is a wrapper around that. Now, there's another thing I wanted to mention. Microsoft is betting heavily on Docker, and they like the workflow so much that they wanted to bring that to Windows developers as well. And so what they announced at Build 1 month ago, they did a demo of a Docker daemon implemented in terms of Windows Server primitives instead of Linux primitives. So in the next version of Windows Server that has a preview this summer, I think in August, they will have the same kind of isolation primitives that Linux has, and they re-implemented Docker Engine on top of these primitives, which means that with the Docker client, you'll be able to schedule Linux workloads and Windows workloads in the cloud that you choose to use. So Docker for developers, typically when you're a developer, you build what is called a Docker file. You don't start from scratch. So Docker file specifies all the stuff that's going in your image. And there are a bunch of official images on Docker Hub that are maintained by the various projects, like Ubuntu, or right now Couchbase. So the reason I'm here today is that Couchbase did the work of creating an official Couchbase image. And so it's available now on Docker Hub. And you can just do a Docker run Couchbase, and it will just get the official Couchbase image and run from it. So you inherit with a from directive from a base image. And then after that, you have directives that let you copy some files into the image, specify where the working directory is, run some commands to compile or install packages or do things like that. The command or an entry point commands specify what's going to be run by default when you're running the image. And then once you've built that image in your source directory, you do a Docker build, assigning a tag, -t, that creates the image name. And then you can do a Docker run with that image, and it will create a container for that image and run it in there. You can also compile your app inside of containers. So there are lots of integration with CI systems like Jenkins. Docker Compose, it's a declarative format for specifying microservice-based applications that are based on several containers. So here is a simple example of what it looks like. I have a web app here. It's in Python. So I just say build here. The command will be python app.py. I specify the port mapping for my application. So I'm going to to map the port on my machine 5000 to the port 5000 inside of the container. I can specify some volume mounts. So I'm going to mount the current directory into the /code directory in the container. And then I can specify links. So here I'm going to link another container called Redis, and I'm going to give it an alias of Redis. What that does is that the next container I specify is Redis. I just specify image Redis. And what that will do is that if I do Docker Compose up in a directory where that file is, it's going to spin up these two containers. And when I'm in the web container, if I ping Redis, the link is creating an entry in etc host on that container so that Redis will just tie directly to the Redis image. And I'll show you how to use Compose with Couchbase. Docker Machine, that's one of my favorite utility. Very quickly, when you run Docker, you run a bunch of VirtualBox instances with boot to Docker on your laptop. But very quickly, you want to start deploying some in Azure, some in Amazon, or your cloud of choice. you can use Docker Machine for that. So Docker Machine is a simple utility. It has a bunch of drivers for all the cloud and virtualization providers. There are some options that are driver specific. So here's an example for Azure. So here I say Docker Machine create -d Azure. And then I specify my Azure subscription, my certificate, which region in Azure I want that, the size of the VM, and things like that, and I assign it a name. Once I've done that, it's going to provision that VM, install Docker daemon on it, set some certificates that it will just copy locally on my local machine. So then after the provisioning is done, I just can connect to that Docker daemon. Docker Hub is where all the images live, and now there's a Couchbase image in there with several tags. I think the latest is 303 or something like that. However, what I'm going to demo, I like to live on the bleeding edge, so I'm going to demo a 4.0 beta version of Couchbase here. And then we have, so Docker is not a non-for-profit. We're a private company, VC-backed, and so everybody is asking me, okay, you're doing open source projects. That's fine, I'm good, thanks. We're doing lots of open source projects, and we're giving that out to the community, but we also want to make a buck. The way we make money, our revenue model, is based on Docker Hub Enterprise. So that's a version of Docker Hub that you can install behind the firewall to manage your private images for your teams. And then Docker Swarm. Very quickly, when people start playing with Docker, they use it in development, but when they want to put it in production, the question begins, how do I orchestrate all these containers that are going to run on many machines? So when you're using Docker engine in development, maybe you provision your VMs with Docker Machine, and then you have a bunch of VMs, some local, some in the cloud. But every time you want to target one of them, you need to change your environment variables, and you use the Docker client to talk to the Docker daemon on these various machines. What Swarm is doing, it's a very elegant and simple architecture where we put a daemon in front of all these Docker engines. We tell these Docker engines to register themselves with a discovery service with their IP address and their ports. And then we start Docker Swarm to say, I'm going to manage this cluster. And what Swarm does is that it connects itself to the various Docker engines and acts as a front end for these. And so when you're on the Docker client, you're just targeting Docker Swarm. And you say, I want to run a container. And you can specify some constraints. So I can say, I want to run that container on a Docker engine that's labeled with SSD, because that's where Couchbase is going to run. It's my database. I want a fast disk in there. Or you can say, I'm going to run my web front end, but I want the Couchbase server to run on a different machine than my front end. So you can use affinities like that. And Swarm is just going to transparently provision your containers on different Docker engines based on the constraint that you specify in Swarm. The beauty of it is that Swarm is using the same API as Docker. So you're talking to it with a Docker client. There's no need for a new client for that. It's doing a bunch of things like resource management, advanced scheduling, the discovery is pluggable. By default, you use a token that goes into Docker Hub, but you can also plug etcd, console, Zookeeper, or whatever you want, or even files. And right now, Swarm is integrated with Machine, so you can use Docker Machine to provision Swarm clusters. It's partially integrated with Compose, and there's a Mesos integration in the work. The last thing I wanted to talk about is Kitematic. When I gave talks about Docker at Microsoft, many of my colleagues told me, oh, you spend your time in the terminal on the command line. Isn't there a UI for it? So back in these days, there weren't any UI. Now there's one for Mac. It's called Kitematic. I'll show you how it works. It's a very nice way to get started with Docker. And then you can deploy anywhere. We talked about the community. I talked briefly about DevOps. I think one of the reasons Docker is successful is that DevOps is really taking off as a practice in the same way as Agile did 15 years ago. And so Docker is the right level of abstraction for implementing a DevOps approach where the developers can focus on their code, their libraries, their packages, their app and data. And then they pass the container as an artifact to the ops team who can take care of logging, remote access, orchestration, network configuration, and things like that. Plugins, I talked about that. I'm going to go a little bit quickly because I'm running out of time. So Couchbase on Docker. So there's an official Couchbase image in Docker Hub. So in order to run Couchbase on Docker, you just do a docker run -d, so to start it as a daemon. You can attach a volume so that you can mount a volume in your container so that the data of your Couchbase database is going to stay on the disk and you can start it later. You can, so the mount point is /up Couchbase /var. You can do some port mapping. By default, I'm just mapping the default port, and then you can apply a name to it. So once you do that, you end up with a Couchbase running instance, and if you go to that port, you will see the admin UI. And what I'm going to demo to you today is a small Node application that the Couchbase team has been building with a very nice and fancy JavaScript UI that's talking to a Couchbase server in the back end. And so I'm going to run it from Compose. So that's what the Compose file looks like. So here we have our travel application. It's our travel image. The image is there. So that's an image that's been pushed to Docker Hub, but you can build it yourself from the code base. And I'll show you what the Docker file looks like. Here I'm mapping port 80 to port 3000, where it's running usually. And I'm going to link it to the Couchbase image, to the Couchbase container. And the Couchbase container is running the server enterprise 4.0 beta. And there I just map all the ports for it, and I'm mounting it to /home Docker Couchbase, which is, so that's the home directory of my user on the on boot to Docker on my local machine. And so when I do a Couchbase Docker compose up with that compose file, it's just going to start both and show me the logs. So let's go for a demo. So first I'll show you Kitematic. So that's what Kitematic looks like. So here I can search Docker Hub for Couchbase. And here I see the official Couchbase image, but there are a bunch of other Couchbase images, and I'm pretty sure maybe some of you have created some of these, so you would recognize yourself in there. And as you can see, Couchbase is pretty popular, so I'm glad we have an official image right now. And so once you have one, you just can say, oh, I want to create a container. It's connecting to Docker Hub. It's downloading the image. So here it should go pretty quickly because I have one running already. And boom, it's running it, and I can view the logs right away. So if I click here, I view the logs. My server is up. And I'm going to stop it. And there I can see, so I can see the logs. I can set some settings like the ports, the volume mapping, and things like that. So you can all do that from there. And if you have a running one, let me start this one again. You can also launch a terminal that's going to launch a terminal that lets you do a Docker PS for that Docker engine in there. So that's one of the quick ways of getting started with Docker. So actually here I have a shell terminal inside of the, if I do a PS -ef. So here I'm inside of the container that's running my Couchbase server, and I can go look at the logs or things like that. And now I'm going to show you a demo. Let me stop that, because I had started it earlier. So, and while I'm stopping this guy, I'm just going to show you the code. So that's the try-cb Node.js, the travel app, for the Node.js travel app. You can see the Docker file for that app. It's a CentOS image. It's installing a bunch of stuff, including Node. And then it's taking the source code of the app and installing it. And then it's running npm install on it. And then it starts the app with app.cmd. So that's a simple Node app that's using Couchbase. And the Docker compose file is the one I showed you, where I'm running this image, mapping some ports, and starting the Couchbase server. So let's do a Docker compose up. So it starts the Couchbase server, and then it starts the app, I have one step that I need to do where I need to provision. Oops. So I need to provision the database indexes for that database, even though I have mounted my /home/docker/pat or /couch directory to it. There are still some indexes that need to be provisioned in memory, so that curl is doing that. So I'm doing a post to my application. Boot to Docker IP is giving me the IP address of the boot to Docker instance that I'm running. And I can show you what that looks like here. So boot to Docker IP, that's this IP. And here I can see in Docker Compose that he's creating indexes. But my app has started already. So if I go in the browser, and I go to Couchbase Travel, and I do shift reload, so it loads my node application. Let's see if the database has finished provisioning. If I type SFO in there. So it's doing autocomplete of the airport code. So I can say, OK, I want to start from San Francisco International. And when I'm doing that, let's see what we see in the logs there. Because we should see a query. We should see a query somewhere in there. Yes, so here I'm, oh no, so that's before I stopped. Let's continue using the app. So I'm going to go to, because I'm French, I'm going to Charles de Gaulle. I'm going to leave from today. It's a quick run to the airport. I'm going to try to find some flights. So here it's doing a request in the Couchbase DB. Oh, and we can see the request here. So it's creating a query, and there in Compose, so when in Compose I can see all the logs for the query that are happening in the database. The beauty of this is that if I'm a new developer in the team, instead of having a long README to read to set up all my environment, I just need two things installed on my machine, Git and Docker. So I do a Git clone of the repository, then I do a Docker Compose app of the application, and I'm good to go. Then I can start developing. So that really, to me, Docker is really about developer agility. That's the main attraction here. And so here you can see I found my, so that's kind of working. So all the code for this in that GitHub repo with instructions about how to run it with Docker. And I sent a pull request in there to add a Docker Compose file that I showed you. All right. Yeah, so that's in essence how you can get started with Couchbase and Docker. It's pretty simple to use. You can find many of my slides for other talks that I gave about Docker in general and Docker on Azure especially at my SlideShare account. Lots of docs on docker.com for how to get started. And that sample application is on GitHub, as well as the Couchbase image, which is in the Docker Hub registry. So we're a startup. We're in San Francisco. We're hiring. I think we're 130 or 40 people right now. And there's a bunch of references to this. And I'll just post my slides to SlideShare so you can find them there. Right. Great. For once, I finish in time. Do you guys have any questions? Thanks. Yes?
Are you guys not supporting boot to Docker?
So the question is, don't we do?
You recommended Kitematic as opposed to.
Oh, do we not support boot to Docker anymore? Because I talked about Kitematic. No, we definitely support boot to Docker. That's the thing that many of us are using every day. Kitematic is just another option. And actually, Kitematic is using boot to Docker behind the scenes. So it's starting a VirtualBox instance and all that. It's just an easier way for developers who are not familiar with the command line to get started with Docker. Yes?
So how would you go about setting up a multi-dimensional Couchbase cluster to mimic a staging or production environment locally to try to replicate what you're doing?
Yeah. Yeah, so the question is, how would you stage a multi-host Couchbase cluster instance? And so for that, if you go to the Couchbase official image, let let me see, Docker Hub, Couchbase. I guess the image is a little bit too early, so it's not fully indexed in there. So if you go to Dockerbase, to the Docker Hub Couchbase image, there is documentation about how to set up clusters. If you go down there, so that's a single host example that I showed. But they have documentation about how to set up multi-processes on the same Linux host. And I wonder, yeah, and they even have one with multiple hosts. And one of the things that I like to play with is to start using Swarm to just provision your Couchbase cluster using constraints and affinities. I didn't have time to do that for that demo, but that's definitely something that's super possible. Yes? So the question is, how does Swarm compare with Chef and Puppet? My simple answer would be it doesn't. Yeah, they solve a different kind of problem. Swarm is really, so first Swarm, you need to provision it. So you need to provision your Swarm cluster. Many people are going to use Chef, Puppet, or Azure Resource Manager, or Amazon CloudFormation to provision their Swarm cluster. Because Darken Machine is kind of limited for the kind of options it gives you for provisioning a Swarm cluster. And here I'm thinking about like adding options, adding labels to the Docker daemon when it starts, or specifying drives to mount for valid Docker to live on, maybe specifying SSD and things like that. So there's a lot of that heavy-duty work for provisioning Swarm that when you do that for production, you would need something like Chef, Puppet, Ansible, ARM, or CloudFormation, or one of these configuration management tools. So I'd say they are complementary in that way. Now, once you have provisioned Swarm, the view of Swarm is that you're deploying all your workloads in containers. And so there, I'd say the only thing you need is the Docker client. However, I've seen some customers doing some interesting setups where they use configuration management tools to build their images. So because they have a bunch of Chef, Puppet, or Ansible scripts already, and so in development, they use Chef, Puppet, or Ansible inside of the images to build the images. Then in development, they're using the Docker engine for working because it's very fast and gives you an agile workflow. But then in production, they use these same scripts, Chef, Puppet, or Ansible, on VMs on the server side. So then they run on bare VMs instead of running in containers. So that's one option. I'd say this is one of the ways where they can work together. Yes?
A couple of words. How is a Docker orchestration different from Kubernetes, Mesosphere,
Yeah.
Azure, and all those things? Because more or less they're doing the same thing, so why choose Docker and not other options?
Yeah. So that's a big question. So the question is,
Ivan, why don't you come up and ask that one?
okay. Yeah, so I think time is running up. I'll stay here. Let's come discuss about this, because this one deserves a little bit more time.
So I just want to thank Patrick again. I want to thank all of you.
Thanks very much.
There'll be Docker resources and Couchbase resources up here in anything you want to talk to.
Thank you.
Much.
Thanks.
I thought that was really good.
Thanks. Yeah, it's a great app.
Ivan works for us.